In the last video, we wrote a short script that generated a visualization of an exponential decay curve tied to a hypothetical chemistry experiment. That script set up a time vector to represent time during the experiment. Then it calculated concentrations at each one of those times, and then it plotted the results. If I run this script, we'll see a nice graph with an exponential decay curve in concentration versus time. Now this is a good start, but what we really want in a scientific graph are axes labels that are complete. So we probably want this axis to say concentration rather than just guessing what C is. And possibly even more importantly, what are the units of concentration so we know what these numbers mean. And likewise, the time axis, maybe this should say time and give us units of minutes so we know what these numbers mean. Also, in terms of aesthetics, we have all this extra white space up here, and we would rather have this white space used for plotting data, not for just blank space on a graph. And there's also some extra white space over here. So maybe we want to get rid of this white space as well. So let's look at how to do this in R. First of all, in terms of controlling this plot region, it's one of the key things to having full control over a graph in R. You need to be able to change the margins, or the amount of space there is between the edge of this canvas, and this I call this white space of this whole graph the canvas. There's going to be a certain amount of space for a margin between the edge of the canvas and the edge of the plot region. And we're going to have four numbers for that. There's going to be one for the bottom, there's going to be a margin on the left, there's going to be a margin on the top, and there's going to be a margin on the right. The way you set margins in base R graphics is using a function called par, P-A-R. Par gets you at a whole set of graphics parameters that are basically global parameters that all of the graphics functions that you call use in order to determine the shape of the plot. So the graphics parameter that I want to look at here is the MAI parameter. So I'm going to call the function par, and if you pass par just the name of one of the parameters, in this case MAI, and I'm going to put it in quotes because it needs to be a string, this is how you get the current setting for that parameter. So if I call par on MAI, I get the numbers 0.99 something, 0.79, 0.79, 0.40, etc. What these are the margins in inches, that's what MAI stands for the four different sides of the canvas. And it goes in this order. The 0.99 is from the bottom of the canvas to the bottom of the plot region. The 0.79 is from the first 0.79 is from the left edge of the canvas to the left edge of the plot region. The second 0.79 is from the top of the canvas to the top of the plot region. And the 0.40 is from the right of the canvas to the right of the plot region. If you look at your plots, these numbers should make sense relative to the amount of space that you're seeing. And again, these numbers are all in inches. So let's say I want to change those values. Well, I use the par function to do that as well. And I can use the par function to set a given parameter by calling the argument as that parameter name. In this case, it's MAI, sorry, not MAR. And I want to set this to a vector of four numbers. And they're going to be different from these numbers. So I can quickly create a vector with the C function. Remember, a C function is a quick way to make a vector with a sequence of values separated by commas. And I want to keep the size of the margin about the same on the bottom. So that first number, I'm going to keep it about 0.99. I'm not going to worry about too many digits of significance here. The margin on the left, I'm going to leave that the same, 0.79, because I have axes labels there and I need to make sure there's room for those. But I have all that extra white space on the top and on the right. So if I want to cut this down, let's say I want to bring it right to the edge of my graph. So I'm only going to put 0.1 or 1/10 of an inch of space on the top and on the right. So calling the par function lets me reset one of the graphing parameters. The graphing parameters I want to reset is the MAI parameter. And I'm going to set it equal to this vector of four numbers that is an adaptation of these default values. So if I've done this right and I run this again, I now have much less space at the top and on the right. So that was my first goal. I wanted to get rid of that extra white space. Now I have a nice tighter looking graph here where I'm not wasting a bunch of space. So the other thing that I wanted to change here was to put more meaningful labels on the axes, especially giving some units to the numbers. And I can do that with more arguments to this plot function. I can change the label on the x-axis by changing the xlab argument. So the xlab argument is expecting some sort of character string to say what is the character string that I should be putting at that label. So if I want to change the x label, which is the time axis, and say I want to call it time, and I want to make the units for that axis minutes. So in parentheses, I'm going to put min for minutes. Again, I can rerun my script and see what that looks like. Oops, I've got an error. Oh, I forgot a comma. It's very important when you're adding arguments to remember to add a comma. Let's try that again. There we go. Now our x-axis is labeled time, and we have, importantly, the units here, so we know what these numbers mean. All right, now we can also add a y label. So for the y label, we have concentration. Again, this needs to be a string. I'm going to spell out concentration rather than just a C. And then our concentration is in milligrams per liter. So one way to specify that is mg/L for milligrams per liter. So let's take a look at what that looks like. Double check we have our commas. That's good. And again, we've got concentration and we have milligrams per liter. This is great, but I want to take it one more step, because my preference for units is to use, rather than using these order of operations ambiguous operators for division, I like to use exponents. So my preference for units is to show this as milligrams liters to the -1, or milligrams per liter, kind of the same way that I typically do dimensions. So how do we do exponents? And we're not going to get into this too heavily right now, but I just want to make sure you understand that you can do it. If you use an expression rather than a string for a label in graphing in R, that expression will be interpreted in a language that's called plot math, which is just a special formatting language that lets you show math. And if you're familiar with things like LaTeX or other formatting languages like that, you might be somewhat familiar with this. But with the expression, we have some special codes that we can put in here to specify this, these units, and let me use exponents and have them be rendered in the label on the axis. So in this case, if I want this expression to be correct, first of all, white space in expressions doesn't mean anything. You have to tell it specifically where you want space. And the way you do that is with a tilde character. So anytime I want space between something and the next thing in an expression, I need to use the tilde character. And I could put all the white spaces here in the world and it wouldn't matter. So that's one thing to get used to. Also, when you have special characters like parentheses, parentheses mean something in plot math, but what I want to do here is actually show a parenthesis character. So to do that, I need to put the parenthesis in quotes to make sure it interprets that as regular text as opposed to some sort of code. The other thing you need is you do need to separate the expressions in here somehow. You can't just have white space with nothing there. But if you need to separate them but not create any space between them, you use the asterisk character. So in this case, I want a parentheses immediately followed by an mg. So I'm going to put the asterisk character in there. Now, I don't need a division sign anymore because I'm going to use an exponent, but I do need space here. I want a space between my mg and my L. And the way that you specify a superscript in plot math is you use the upward caret. And I want to put in curly brackets more than one character, because I'm going to have more than one character in my exponent here because I want it to be a -1. So these curly brackets won't show up. It's just a way to tell plot math that I want more than one character in the exponent of L. Again, between my L to the -1 and the closed parentheses, I don't want any extra space. I'm going to use the asterisk. I'm going to put quotes around this closed parentheses because I don't want it to interpret that as code. It needs to interpret it as actual part of the expression. And that's it. So this is an involved language, and if you do a help on plot math, you can learn more about how to handle it, how to handle the math anyway. That'll give you some documentation here. And once you get used to these codes and how to separate things with tildes and asterisks, that's most of it. So that's something just to give you a hint of what you can do here. Let's take a look at what this looks like. And my graph popped up in behind, so I'll go ahead and bring it up this way. Now we can see that, yes, we've got an exponent there, but we can't see all of it. And that's because our margin is not big enough here. Because we're using an exponent, this text is now taller and it's going off the edge of the graph. So another thing that we need to do here, I'm going to close all of these graphing windows, is we need to think about that left margin. We need to make it a little bit bigger. Right now it's at 0.79 inches. Let's give it a couple more tenths of an inch here and turn that up into, I'm sorry, that was 0.79. Let's give it a couple more tenths of an inch. Let's change that to 0.99. So we'll make it the same as our bottom. So this is the left side margin, remember. I'm going to run this again. And again, it popped up behind. And now we have lots of space and we can see our milligrams per liter in our exponent is showing up. So that gives you an overview on how to make a nice formal looking scientific graph with complete annotation of what you would expect to see, as well as how to tweak the white space to make sure you're using the canvas the way that you want to.